Hello everybody, again welcome to webinar which we named Get More from Your Infrastructure Projects. My name is Tomáš Nedvorský. I'm Senior Technical Sales Specialist in Autodesk based in Prague, and the goal of this webinar is to show you how Autodesk portfolio can help you with your infrastructure projects and how you can combine different products within our portfolio to really reach your goal, which means to finalize and finish your projects in better quality and in a better manner, and definitely more efficiently. So let's have a look at the beginning what we are gonna to talk about, and this will be at the beginning. Just very briefly I will talk about BIM, and then after this I will look at each not each, but on some project stakeholders like road designer, surveyor, we will also touch bridge designer, tunnel designer, so how they can benefit from Autodesk portfolio for their projects. However, at the beginning I want to give you a quick overview what's happening at this point across the globe, of course with the focus on Europe, where we have different BIM mandates, BIM standards in place. Somewhere it's let's say on the way, somewhere it's already in place. If you are talking for example about Germany, they are planning to have it in 2020, some BIM mandates. In Czech Republic, for example, in 2022. And of course, this initiative is going across the entire European community, and not only entire European community, but also in wider scope. But if we are talking about the European community, then this definitely is a very important initiative, because it's a recommendation of European community to each member to implement BIM on their projects, which means all state-owned projects from some amount of a budget higher, they will mandate BIM. So this is something which is happening, and we can expect it also in Romania very soon. So what is BIM? If we are talking about infrastructure, for us it's a really process where a 3D model is and I would say placeholder for informations which are added during the life cycle of the project, and where this amount of information is obviously growing from project phase through build phase up to the operating phase, when all these information are used and managed. However, from this perspective, it's, let's say, wider picture. For you as a designers, it also brings benefits in a different manner, because in fact, if you have one multidisciplinary model where you can bring different data in from just GIS data through really design of civil, but also another structures, if you have some buildings, etc. And if you have one federated model, then you can benefit from this, having possibilities to get, of course, faster documentation, quantification, but also really, for example, 4D and maybe even 5D sequencing, coordination, and basically being able to get all information very easily from your project. And you can also connect then later on this information to your ERP models, send it for scheduling, and so on and so forth. So it's really also benefit not only through the entire life cycle of the project, but also for you as a designer to use BIM model. And in Autodesk, how we see it as a really connected BIM for infrastructure, because it's a of course, very interesting if you have a model with information on your desktop or on your laptop, but it's much more important that you are sharing efficiently these data with other stakeholders on the project, and then they can use it through the entire life cycle of the project. So I will be also talking about how you can share this data with other stakeholders, and this will be also important part. So and how people can see benefits of BIM on their projects. And I'm not going to read these numbers, but definitely it's about a better understanding. It's about proper coordination with fewer errors, with optimization, and this definitely better cost predictability, because many projects are running over time and over budget, and this is also why European community is pushing in this direction, that the state-owned projects or projects which are financed by government or European community, they will have to comply with BIM standards, with local BIM standards. So this is something where we are really heading for. And of course, if we are talking about infrastructure, we are always talking about huge projects which will be definitely over the some threshold of this money, and they will be required in BIM. So let's have a look for the process. So I will start, of course, from the beginning, from a land surveyor, how a land surveyor can use some of our tools, and what he can, how he can benefit from Autodesk, wide Autodesk portfolio. So if we are talking about land surveyor, of course, he can or he should take different sources like GIS data, reality capture, other BIM data, you know, and to create one model of existing context where he can later on give it to the designer for proper design. So, and of course, now we could talk even one entire webinar how he can benefit from Autodesk portfolio, but here I picked several points what is let's say relatively new, and how he can use this data, existing data, to create one model. And the first one is how to bring GIS to BIM, because GIS in infrastructure project is very important, no doubt about this. And of course, bringing this data efficiently for a designing process is very important. However, in Autodesk, we see it also in our way, basically that later on BIM data can go back to GIS, and then that the GIS community can benefit from this. So we are working on this. I don't want to say that everything is ready yet, but something which you can already benefit from is proper possibility to connect data from ArcGIS. So ArcGIS is a really rich source of GIS data, and we are collaborating with Esri, producer of ArcGIS, to bring the data to our products. So at this point we can bring it from InfraWorks, and what we can do is to connect the data, basically to select the area which you want to use. Of course, in InfraWorks, you can connect to ESRI, and then you can choose which type of data you want to bring in, how to map it to InfraWorks database, and bring all these data on, let's say, one click, and you can start to use it. Then you can stylize it. Basically, you can say which rules to be applied. For example, if you have some land use based on which area you are, which area is this, if it's, for example, residential area or in industrial area, so it can be colorized, and then you can work with all attributes which are associated with this. But what is important is that it's live connection. Basically, you can imagine that the data are collected, so ArcGIS is even improved and enriched on the way. So if, for example, survey is adding more information to the ArcGIS, so these data are not only in ArcGIS, but lively that we can bring them to InfraWorks and to get all information which has been collected on the field. So this is where we are at this point, and something, as I mentioned, we are working on, and you can expect even more improvements later on. But even at this point, it's very important that we can bring all this data in. Another, let's say, new technology or relatively new technology is reality capture. So being able to really collect enormous amount of points on field, it's, let's say, already everyday business, but how to deal with this in our products. So, and again, I picked up just some let's say important points which I believe that are important, but the process is, of course, let's say a little bit more complex in respect what you want to achieve. And here I will be talking about terrain and horizontal features, but of course if you need to extract vertical features, we can do it as well, and so on and so forth. But as far as terrain is concerned, you know, so we can bring the data. First it can go to recap. From recap we can bring it to InfraWorks, and here is the result, you know, combining existing context from in InfraWorks and laser scan, and then what we can do, we can extract the terrain, basically to create a digital terrain model with some rules, how it will be processed, how the points will be used for DTM creation, and you can later on process it, and system will automatically from structured data he will recognize what is really terrain, what is vertical feature like tree or lamppost, and you are receiving a DTM model which can be later on used for example in Civil 3D and other products, Revit for let's say design, because of course having detailed DTM is nice, but you in InfraWorks, but then you can use it in detailed design tools throughout the designing process, and I will talk about this later on throughout within our webinar. So you can see that the system automatically recognizes which points are, let's say, correct and defining terrain, and which are, let's say, some noise or a vertical feature. So we can recognize it and create a model. And here is example of really 6.5 kilometers of the road, and here you can see that there were some cars passing by while taking a survey, and system automatically recognize it and recognize it as a noise which will be which was basically eliminated. And then we can go to the linear extraction, which means that it's nice to have a digital terrain model, but for design it's important also to know where is, for example, a center line, where is edge of the road, and so on and so forth. So what we can do, we can automatically create or extract feature lines, which means this horizontal features, like here is the center line. So I will pick at the beginning where I have markings, at the point, another point of another marking, and system is automatically extracting this line. And don't forget, again, we are talking about long model, so the system is recognizing it automatically and automatically creates this feature up to where the road marking is done. And of course then you can continue with edge of the road, with edge of the lane, and so on and so forth, and you can really do it very quickly and very efficiently. So now for example here is some widening, so I will pick again 2 points, and I assign a different style to recognize that this is not feature, this is not center line, but it's maybe edge of the lane. So you can see really in a matter of seconds we received really entire the feature line along the entire length of the existence within the model. So these are the features, and as I mentioned, we can also extract vertical objects like trees, lampposts, and then it can be brought to later on for use in Civil 3D, because we have connection between InfraWorks and Civil 3D for detail design. So from lens surveying perspective, so we can process laser scanning. In fact, I haven't showed this, but you should use Recap, which is a tool where you can bring different laser scan formats and prepare it to the format for use in Autodesk products. And not only this, you can make transformation, coordination transformation, maybe because maybe you have a survey in UTM and you have to convert it to the local coordinate system. Then you can bring it to InfraWorks. You can extract DTM model and feature lines and vertical features and so on and so forth. You can even add conventional survey. Basically, maybe a surveyor went out and he did another survey by classical total station and so on and so forth. So we can bring it there as well, and from all of this we can create a model, and this can be created and brought to Civil 3D and use for design. So this is really in glimpse how a land surveyor can benefit from Autodesk portfolio. So let's move further for road designer. So road designer, what he can do, he can combine conceptual planning with a detailed design. So depending in which phase of the project he is, he can use conceptual planning in InfraWorks, and then to bring it to Civil 3D for detailed design. Or of course, if he is in the next step, he can start directly in detailed design. But here I want to show how he can benefit using first InfraWorks, making design, conceptual design, and then go for detailed design. So here is part of land, and in fact this is in Poland, where we had the data, GIS data and survey data. You see that in InfraWorks I have what we call land use, so I know this coverages, if it's a tree, if it's forest or industrial area and so forth. I have also, for example, DWG file with cadastral information, which you see this yellow lines. It's giving me information about cadastre, basically the parcels, and then I can start to design my road. So in fact here my task is because here is a village, so I should go throughout out of the village, so make bypass, and because this is really valley or hilly area, so and I'm in valley, so what I will have to do, I have to go on the other side of the valley, and you will see that I will have to create some structures like bridges and tunnels just to show you what are the possibilities. So now I sketched the center lines. I'm really saying sketching, but of course you can define the radiuses, spirals, and so on and so forth. And now I'm specifying what type of road I am using, and now I decided that here, because I'm in this hilly area, I will create from this point to that point, so I will create tunnel. So basically me as a road designer, I'm doing a little bit of job of tunnel designer and a little bit of job of you will see bridge designer, because I'm defining where I expect some structures on my road. But of course then what I should think about, you know, because system is optimizing it and system is automatically adding this information on the top surface, but now I have a possibility to define profile or redefine the profile to bring this model under the ground to have really tunnel. So what I did, I changed my points. Of course, I can add additional points. I can change information of my vertical curves. Based on, of course, my standards. And now here it's another part where I have to cross some railway. So it's not only about tunnel, but it's also about railway. So you can see that here I can see my alignment, better said, center line is not only alignment, it's center line in 3D. And in fact, I can move these points either in a profile view, which I'm doing at this point, or I can do it also in 3D, because these points, you can see this points which I can redefine the profile are also visible in 3D view, and I can redefine 3D view. And now I'm just saying at this point I expect bridge coming or starting at this station, ending in this station. So I have I'm defining information, and system is automatically creating structure, bridge structure, and I will cover it later on how we can deal with details of structure. So now let's have a look to the detail design. So we did very quickly sketching of the road, but with all important information. And now I want to bring it to detail design. So what I will do, I will create a new drawing based on the template. So here it's because it's in Poland, so I'm using Polish country kit, but of course we have Romanian country kit. So basically you can start your drawing based on Romanian country kit with all necessary styles and rules implemented already. And now I'm just saying to system from which InfraWorks model I want to bring the data in. Basically, I'm connecting to InfraWorks and I'm specifying which area I'm interested in. I can bring entire model, but I know that detail model, detail design I will do in some parts only. So I am redefining limits that I am not bringing too many data into my to Civil 3D and designing this. So I will answer one question here is, does it software applies to gas pipeline? Yes, we have also possibility to create pipes, and you can create in conceptual design also pipes, and you can bring it to Civil 3D as well. I'm just not showing it at this point. So now in detail design I have information from InfraWorks about alignment, profile, where is the bridge, and now I'm just showing other functionality of Civil 3D where we can use assemblies which are already existing, or you as a customer you can design your custom subassembly which can be later on used. So here I created a tunnel subassembly based on specific requirements, what will be the shape of the tunnel. So I created something based on the requirements. In fact, it was one customer, he wanted to see tunnel like this. And now I'm saying in which regions, in which parts we will apply different assemblies which I created. So basically I said, okay, from here will be tunnel, from here to here will be cut fill, and system is doing it automatically for me. And you can play with this, you know, so maybe I want to do more. But now at this point I'm quickly creating cross sections because I want to see how it's look like. So basically I'm saying where I want my cross section views, and just very easy I will create my views. And again I just want to stress that having Romanian country kit, this will look based on Romanian standards. And here you see that I have tunnel, I have cut fills based on how it looks or where the existing ground is. So I have all this information immediately available. And as I'm working on, then I realized, okay, I don't have see here my buildings. So of course, again, I can connect back to the InfraWorks because I have this information there, and I can bring this information in. And oops, you see what happened. You know, I designed my road, and I didn't take too much attention to buildings, you know, so just as an example, of course, now what we can do. So now I want to make some retaining wall because these buildings should stay there untouched. So I'm just changing my detail design, and I say, okay, I will use my retaining wall, and of course I can even do my you know, base of the retaining wall in some geological layer, so we have all this information available, and I will just rebuild very quickly my design, and you see as I'm designing my road, all subsequent views like cross sections, etc., are redesigned as well, or better said, redrawn. So which means, of course, you can calculate volumes, you can make analysis, and all of this will be automatically updated. So, and now you can do different analysis. So which means that I was talking already about volumetric calculation. You can calculate areas and so on and so forth. But here is another example that we can make different analysis regarding, for example, what we call swept path. You know, so turning lanes. If you can imagine that if I have some maybe I'm in town, you know, or here is some logistical center, so I want to analyze how the big tracks will be able to maneuver throughout this design. So I'm using what we call vehicles, design vehicles, which you as a customer, you can define. But again, we have we have Romanian standard vehicles already in place, and you just can pick them, you know, modify the swept path, and to see really if the vehicle will be capable of coming in, and you can visualize it, and then of course you can communicate this information with stakeholders, with investor, just to prove that the area is correct, and you can do this. And in fact, I didn't talk, you can make also visualization directly from InfraWorks to collaborate with other stakeholders and to let them know what is necessary, what you can do. So just from a road design workflow, we touched based on this, but conceptual design done in InfraWorks. The information can be moved to the Civil 3D for detail design, where you can create communication, volumetric calculation, and other analysis. And then talking about analysis, I was talking about swept path analysis, which is done in vehicle tracking. But please realize that each of the product on the way, which means InfraWorks or Civil 3D as well, they have other capabilities also for analysis, like InfraWorks making 3D analysis of obstacles on the road or on the junction, you know. InfraWorks also can make quickly in the conceptual stage calculation of the volumes. However, in detail design, you need much more detailed volumetric calculation based on the surfaces, or better said, the segments of your road, you know, like asphalt and sublayers of the constructions, and so on and so forth. All this can be calculated and analyzed in these products. So let's move forward. Let's have a look for the bridge designer. So how bridge designer can benefit from our products. So here, a bridge designer, you already saw a little bit this during the design of the road. So here is another example, maybe something shorter, designing a bridge, you know, specifying from where to where the bridge will be. But it's not only about, let's say, geometry, because here you have possibility to add also more information, not about piers and abutments only, but now I want to add some railings, you know, so that it will be really much more detailed, so you can add more information. But you as a user, you can redefine the geometry. So basically I want to move or rotate the pier, or I want to even to change the pier, because how it works that we have 3D objects, and we are delivering you basically a library of these objects, but you can design or define these objects, in your library, and then just very simply you can pick your custom peer and you can apply it to all peers in your bridge. So basically it's parametrical, which means that you can change beams, abutments, and all this information as you want based on the library or based on your definition. And then with girder bridges, we are also allowing you to make analysis in cloud. So basically you will send the information to cloud, and system will create, will calculate the stresses, shears, and all this information. And you can check if the bridge is correct, and then you can bring this model, which is really detailed model created in InfraWorks, you can bring to Revit. On one click you saw that I just said okay, send it to Revit, and I have this rich geometry in Revit for detailing. And if I'm talking about detailing, then I am talking about drawings, and I'm talking also about maybe reinforcement and so on and so forth. So I have this model here, and then what I can do, I can make reinforcement. So basically I am defining how the reinforcement will be, what will be the interval distances, and so on and so forth, and I can create it very quickly. And then creating documentation, sections, plan views, you can see the drawing layouts, so I can combine sections, 3D isometric views, and all this information in one drawing. So Revit is really for detailing and for creating deliverables. So this is how the workflows look like. And then just checking what will be the bridge design workflow. So in Inventor you can create these parametrical parts if you need, but maybe you don't need it. Maybe you are happy with all information which are already in library, so you can start immediately in InfraWorks. You can design your detail bridge. You can create structural analysis. In my video I showed you how you can use cloud services. However, we have also structural bridge design desktop software, which will help you to make a structural analysis on your desktop, so you can change other informations and really to have full control on the calculation. And then you can bring it to Revit, and you can make deliverables and all information needed on your drawings. Let's have a look to the tunnel designer. Tunnel designer, it's in fact kind of similar to bridge designer, but here I just want to show you another possibilities which we have, because if you are dealing with tunnels, of course you know that there are different geologic layers. So what we can do, we can model these geologic layers. So if you have for example Excel sheet where you have information about where the borehole is, what are the elevations of different strata, so we can create surfaces based on this, and you can really play with different surfaces, create this surface, create that surface, so really up to you, just switching on, off, looking where it is, and in fact you will see it in a minute. It's not only some block in 2D, but it's really 3D information about different layers, different geologic layers. And of course later on you can make profiles, you can section it, so basically you can say okay, I want to have a look to this particular section, and you see how you modeled entire stuff. So just saying what you want to see in your profile, which strata, so which boreholes, because what we can do, we can project the nearby boreholes within, let's say, 20 meters, that it will be visible, and you will just click and you see, okay, I have all this information with different strata and elevations, and you can you check it. Of course, maybe you know that there is some fault, you can model fault, and you can go with much more details. And then you can use this information for tunnel design. And in fact, in InfraWorks, it's very similar, and here is example how the tunnel can be created in InfraWorks, and it's very similar like the workflow which you saw in Bridges, and now you have all information. You can send it to Revit from InfraWorks, and again the same story. You can create rebar, you can create deliverable drawings, and basically to make all necessary detailing in your model. So, and here is workflow which can be used basically in Civil 3D. We can make different stratas, and of course later on you can make also calculation, because of course different volumes of different stratas, because it's different money involved, so it can be calculated. In InfraWorks, creating really 3D model of tunnel. And again, very similar like in Bridge, you can create your own parts, your own profiles in Inventor. Then you can bring it to Revit to create bill of materials, to volumetric calculation, and also make detailed drawings and deliverables. Let's have a look to the railway designer. So here it's a little bit more like similar to road designer, because don't forget we can extract GIS data, we can extract existing features, because I believe more projects in railway is related to the reconstruction. Of course there are some new railways, but mostly it's about reconstruction of existing. So don't forget we do have tools for surveyor to help with extracting railway tracks, central lines, and all information. We can create surfaces. You already saw it. Land Surveyor can create surface DTM from maybe point clouds or a classical survey. Then we have dedicated tools for rehabilitations. For example, if you are talking about alignment and profile, if it's really reconstruction, we can use what we call best fit alignment and best fit profile. Based on least square method calculation, we can extract it, and to help really designer to have understanding, to have geometry on one point, but also knowing what are the offsets from existing alignment, offsets from existing profile, that he can optimize his design. Then, of course, if we are talking about railway, we are not talking about triple elevation, which we can do in roads, but we are talking about CAN. So basically we have CAN calculation, and again we have rules and all information which are available, and then it can be applied to next step for track assembly. So we do supply several assemblies or sub-assemblies for railway design, but we understand that it is important to create also your own sub-assemblies, and I already showed you that we have a sub-assembly composer where I showed you the tunnel. Very similar way if you need some very specific sub-assemblies for your railway, so we can do it, or you can do it. You have tool for this as well, and you can create your sub-assembly. And then, of course, you can create 3D model, very similar like in roads with different regions, and then you can visualize it in 3D. And I didn't talk about it, but it also applies to the road designer. You can make visualization in Civil 3D, for example, let's say very simple one, but you can also bring the data to 3ds Max, which is our visualization or professional visualization tool, and we do have tool which is called Civil View, which is really connecting dynamically Civil 3D with 3ds Max. So which means if you would change something in Civil 3D, your visualization in 3ds Max will be updated, just for information and to be aware of it. And Railway design is specific, of course, in some matters, which means, for example, platform design. So we do have very recently we implemented tools that in Civil 3D you can specify where will be the edge of the platform, which is dynamically linked to your design. And this can be brought to Revit, and then in Revit you can make really detailed design of your platform. But if I'm saying that you are creating this edge of the platform in Civil 3D, and then in Revit you will create a platform itself. So it's again dynamically linked, which means if I were to move my track, railway track, so then the platform is recalculated, you know. So we are doing this dynamic relationship even across the platforms, across the different products. And of course, you can create bill of materials, volumes, etc. And don't forget, again, railway designer or guys dealing with railway, they can benefit from tunnel and bridge design in InfraWorks for their tools. And last, let's say, important part which I want to mention is chief engineer. Basically, somebody who is responsible for entire project, because of course it can be road, rail, tunnel, bridge. I didn't mention pipes. So everything in what you have in infrastructure, and then there is the chief engineer who should have tool to collaborate with everybody. And also not only chief engineer, but also other stakeholders, they can collaborate. And now I'm talking about the BIM 360 platform where we can work together and where we can upload the different data. System is automatically keeping versioning. So basically, if you upload the file of the same name, system will automatically create next version. And we have here a tool which is in fact in a web browser where you have all information with all details with not only 3D geometry, but without need to install anything. People can access the data. They can check what has been designed from geometrical perspective, but also from properties perspective, information, because BIM is about information. And then chief designer needs to get more information. So what we have a tool which is called Navisworks, and then it allows to put different models together. So basically you can have a road model, bridge model, railway model together. And in fact, I'm here showing another capability which enables to somebody who is not familiar with Civil 3D, who is not familiar with Revit and other designing tool, but what he wants to get quickly a volumetric calculation of, for example, asphalt. So we have a really simple tool to extract the information from model and bring it and calculate it. And so now I see information from entire model, so how many cubic meters of my asphalt or of asphalt I will need on my project, and very quickly go to calculate. But not only this, tool can also do simulation, because if you are making some construction, and here is an example of different project with short road, short bridge, overpass, better set, and pipes and electrical poles, basically much more, let's say, richer as far as different stakeholders are involved. So, and then you can create a timeline, which can be created here in Navisworks, or you can bring it from Microsoft Project or Primavera, for example, and then you can visualize the progress of construction work. And at any time you can stop it, you can interrogate the model if it makes sense or not. You can make also clash detection if the as far as constructability is concerned. Of course, you can check here the safety, if you have enough space, you know, maybe for workers and so on. So it can be used for different purposes, and really nice and effective tool to make communication with other stakeholders. And you know, beauty of this software is that you don't need to know anything about Revit, Civil 3D. It's very easy to use, and also another benefit is that system is making a compression of the data while importing it to Navisworks, and system is also keeping dynamic relationship between original model and new model. So basically, if something is changed in Civil 3D or Revit, then it's also updated here in Navisworks. And here's another example of making animation, showing if the crane will be capable of passing by. And it's not only animation that, okay, crane is moving around, but I can use it, for example, for collision detection. If basically the crane will be moving on the construction site, so I'm telling, okay, it can move with this arm up, but I'm checking if there will be clash with this electric lines. And well, in fact, there will be, so I can check and basically it's for me security warning, this shouldn't happen, so I should take some steps to avoid something like this. And of course, we can do, let's say, hard clashes, but of course it can be within some space. I can say it will be a soft clash and system will calculate it for me. And I can communicate it, I can send this information to somebody else as a picture or as an entire model. And don't forget, I am not sending live data, I am sending compressed model. We do have Navisworks freedom, and then people can check the data even not having, let's say, paid version of Navisworks. This freedom is for free and they can view it. And here you can see what can be a workflow. So basically using BIM 360 tools, we can communicate, we can put data to one source of truth, we can make communication markups and everything in cloud. Then in Navisworks, the chief engineer can view it. He can use even AutoCAD for reviewing data, and for communication, again, he can use BIM 360 for issues if something is going wrong, so he can communicate throughout the BIM 360 platform. So with that, we are coming at the end of my presentation. So just before I will look to the questions, here is my email address and also email address of my colleague who is taking care of Romania. So if you have any question related to the sales and other stuff, so you can also contact Viorel. So he is Romanian guy, so he can speak in Romanian, while me not, so I'm speaking English only, or Czech if you want to speak Czech with me.